and welcome to today's tutorial. In this tutorial we are basically going to um, start up the movement for our main character. For the last video we created these cubes and then we talked about what the game was going to be about. So with that being said, let's get into today's video. So first of all, we have to create our character, and I haven't done that yet. So like I said, we're going to be using a kind of a ball, so we're going to use a sphere um for this game, I guess. And since it's obvious, I'm going to reset the transform first of all. Let me just reset the transform 0 0 0, and then it's obviously bigger than the cube, so when it falls down it's going to have an issue there. Therefore I want to reduce the scale of the sphere, so I'm going to use half of it. That's 0.5, 0.5 and 0.5. So I think this should be okay, and to style it up a bit I'm going to add a material. So I'm going to create add material for this sphere, and I'm going to name this play. So for this one I'm going to color it red. I'm going to bump up the metallicness because I want it to be a bit shiny, and then smoothness would be this way. So now when I drag this material into the game object, there it is. It's like maroon color, I guess. And so this is it. The next thing we'll be doing now will be to create a script for moving this game object. Obviously it's not going to move on its own, so I'm going to right click, go into create C# script. I'm going to call this movement. So let me double click this and open this up in Visual Studio. So I'll see you there. So this is Visual Studio. This is my IDE. So I'm going to get straight to the point. I'm going to start creating variables which I'm going to use. Variables are basically containers for storing data which you are going to use in making code for the game. So obviously you control everything from over here, the coding. There are added components in the game engine to assist, but if you're good enough, if you are a good developer, you can also create yours. That would of course be tedious, but it would be okay if you know what you're doing. So the first thing I will do in my IDE would be to create a public rigid body. I'm going to call this RB, and then next would be my public float speed, speed. So let me default this to 5f. We can of course change it in the inspector if it misbehaves or it's not doing what we planned for it to do. And finally I'm going to declare a vector, vector 3. I'm going to call this velocity. This would be equal to vector 3 dot 0. So those of you who are not familiar with vector math, this vector 3 just represents x, y, z. That's for all three sides, and then I gave it a like a name, a title, velocity, which I'm going to be using later or right now in my update. And I put it by default to 0 because I don't want to give it any value for now, but then I'm going to change it in my update. So right now, after declaring this rigid body, and Another thing we need to take note of right now is the fact that I gave this a public rigid body RB. So if I should save this now and go over into Unity, so this is it. If I should drag this into my sphere and I click my sphere now, it should be available. So right now I can add a component to this because we're going to be using our rigid body. So this is these are the Unity components, and then you can come over here into physics, and then this here it is rigid body, or you can just use this search bar up here and then type in rigid body. Of course, if you type in the first two letters, it's going to bring up the first few or the options available which have RI in their spelling. So we're going to be using the rigid body for this video. So this is it. Now for now I'm going to remove gravity, so because we're just going to test it out if it's moving or not. Now I can just drag this RB and put it here, so this makes a reference to it. But there is a problem with this method, that if your character keeps dying and respawning in a game, this at some point will just go blank or go empty, and then there will be no way to actually reference your character. So rather than use this as a public RB, I'm going to make this private. Now private is going to be hidden from any other script or from any form of reference, but then it's going to be understandable. So let's just do it so I can show you what I mean. Now I can turn this to private, rigid body RB, and then in my start I'm going to make a reference to it. So RB would be equals to get component rigid body. Like this is the reference which I make to my rigid body. So now if I save this and we go back into Unity, okay, you can see it's gone. The public reference is gone. And now, just to make sure that this is working, I'm going to put on gravity and I'm going to play this game. So you can see the reference works and it's falling with gravity just as we planned. So let me pause this, or let me get out of the game and off this for now, and let's go back into our movement. Now that we've actually made a reference to our rigid body, the next thing we would do, what I would do in the update right now, is to create a movement for this rigid body. And there is a way to actually do that by default using some of Unity's components, but since we're going to be using only the rigid body, I have my own method of doing this, and this is how I'm going to do mine. So inside here I'm going to create a float, and this float I'm going to call it X movement. So let me use the underscore X and movement, and then this would be input dot get axis raw and horizontal. Then I'm going to close this with a semicolon. Now what I just did right now is create a float X movement. So it's going to check this input. By default in Unity, when I come over here and I go into edit project settings, you can see over here in input axis, the horizontal axis which we are going to be using, this is negative button left, positive right. So that's these are arrow keys on the computer, or we can use it can be the A and D key. And so that is just like something by default in Unity, and it actually reads the input. So the input doesn't go above 1 generally, so it ranges from -1 to +1. That's float X movement. And next thing I would do right now would be to create a vector tree. I'm going to call this horizontal movement. Let's just call it horizontal movement, or let me call it horizontal with an underscore. Horizon. And this right now this would be in this horizontal now. Well, this thing is actually becoming a problem. Let me collapse this. Nice. So in this horizontal movement now, I'm going to multiply my transform dot right, and I'm going to multiply this by the float which it got. So this would be times our x movement. Now this transform dot right, it's just positioning, like it makes reference to actually the transform in the game object. Like there is transform dot forward, transform dot right. So for forward is on the z-axis, which moves forward and backward by which is supposed to move forward and backward depending on your value, whether it's a negative or a positive value. So positive for forward, and then let me use this positive. So let's click on my sphere. This is the z arrow. So when it's positive for transform dot forward, it goes forward. When it's negative, it goes the opposite direction, which is backward. So that's the same thing with the transform dot right. When it's positive, it comes forward. When it's negative, it goes the other way around. So for this game now, we're going to be moving on the horizontal axis, which is left and right. That is why I'm making reference to this transform, and it's on the x. So this transform dot right, basically it touches the x value. That is just the simple simple logic behind it. Now for my next one, now I have my x movement or my horizontal movement. Now finally I'm going to create another vector 3, and I'm going to call this underscore velocity. So it's different from this velocity because of the underscore, and I want them to work together with each other. So they will be building this with each other by with the way we're going to set up the code. And this velocity now would be equal to horizontal and then dot normalized. Nope, not capital. Dot normalized, and then we're going to multiply this with our speed. So this 5f, we're going to multiply our velocity at this horizontal, this the movement times the speed, and then we're going to close this with a semicolon. So this should be okay for now. And then why we're trying to smoothen this out is because when we actually got the x horizontal input dot get axis raw, it's not something raw like that needs to be cooked or something. It's like it gives a value without actually smoothing things out. So this horizontal, or this input dot get axis for, it just gives you a default value. It doesn't try to make things okay. It just checks to see if there is a value and it just brings it out, so it doesn't do anything else. So anytime you use get axis raw, it means you have a plan to make things better or later in the code, right? So that is just what it means essentially. And finally, now what we would do would be to make our velocity, that's our vector 3.0. We didn't give it any value, so right now we're going to use this, and then we're going to set this equal to our velocity. So this velocity has nothing in it, so by default it's 0, and then this velocity, it actually has all the input which we've gotten and calculated and smoothened out. So this would be equal to this by default. So this is just how we're going to move the game object. And right now I'm going to create an if statement. So if is kind of like a condition, mostly if it's true or false, or it's almost like a boolean, but it's not like that. It's either one thing is happening or the other one is happening, or you can just keep giving multiple conditions inside the if statement until you're satisfied with it. That's depending on what you want. So I can go like this: if, okay, let's say if speed is greater than 5, then I can choose to execute the code and then type in debug.log log I am greater than 5, and then end this with a semicolon. And if it's not, then we can use the else statement like this. If it's not greater than 5, then debug.log maybe I am less than 5 or something like that. Well, let's just check it out in the inspector. So let's put this way: v, then I am less than 5. So, and then so these are not just the two which you can use, like there is also something called an else if. So else, but then the else if always has to have a condition. Now let's put the else if, and then open and close a bracket. Then right now I'm going to type in if. I'm going to change this actually. I am, let's call this 5. If speed is equal to 5, then print out I am 5, and finally else if this is less than 5, which is the opposite of the if statement, then you can debug.log I, let's copy this, paste, I am less so let's save this now. Let's see it in the inspector. Now let's play this and open our console. So you can see I am 5, I am 5, I am 5, and it keeps going on because it's in the update and it's checking every single frame. So it keeps going on like this. So this is the condition which is true. That means speed is equal to 5. As you can see, this is what we declared in our variable, so it doesn't change. I didn't make it change. It's not greater than and it's not less than. So let's change it now to 6. Let's save it and see what happens. Let's clear this and let's wait for it to load a bit. Nice. So when I play it now, we can see I am 5. No, since we declared it over here in the speed variable, it's public now, so it doesn't really matter. So it doesn't really matter if I change, this to 8, 9, 10. It's just going to be reading 5 since it's public. So what I do now is that I can change this in my speed. In my inspector, I can change this now to 6, enter, and then when I play it now, it should show me that it's greater than 5. So you can see I am greater than 5. And now when I reduce this to 4 and I clear this console and I play it now, so you can see I am less than 5. So that's just the basic concept behind the if statement. Let's make this 5 and let's go back into our IDE. So this is what I will be using right now. Let's clear this. I guess you've learned something extra besides move today, so you should be giving me a thumbs up for this video. So right now what I'm going to do is I'm not going to be using speed. I'm going to clear this debug.log. So if velocity at this one we declared up here, which is equals to vector 3.0, if it's not equal to vector 3.0, then I want us to execute this code, and I want to change the position of my rigid body. So in essence, what it means is I'm going to move it to another direction. So what I would use for this would be rb.move position. So this is like also another function of Unity, or it calls it's what you can use to move the rigid body. That's RB besides add force. So right now we just want it to be set into motion. We want to change the position of this, so this is what it's going to be. We're going to move the position of our rigid body, and the position would be rb.position, and then we're going to add our velocity to it. And multiply this by time dot fixed delta time. We're going to end. Nice. So this is it. With this we've completed our movement. This would make us move the position of this rigid body. So the current position of the rigid body, that's rb dot position, we're going to add this velocity to it. So if we do this calculation, it means this velocity, whatever value it gives to us, would be between -1 and 1. So it can be 0, -1, or 1 itself. And when we set this vector 3.0, that's this velocity equal to the calculated velocity, it means the value would be updated. So if this velocity, that's this one up here, is not equal to 0, then we want to change the position by adding the velocity to this current position and multiplying it by time dot fixed delta time. So it's almost like a time dot delta time, except this, well, it's similar. It gives more of a precise calculation. So let's save this now and see what it looks like in Unity. And we have an error. So let me check this, and yep, this is it. So I didn't spell it with a capital letter, so this should do it now. Be careful when you spell in Unity or any other development environment, because it can actually delay you for quite a long time. So just try to be as careful as possible. Now let's save this and check Unity. Yep, so it's gone, and that was the only bug. So with that done now, let's leave the console and let's play the game now to see if our game object is actually moving. So you can see it is moving. So we're actually making progress, and wow. So it can actually go off the screen now, but then for our next video we're going to see how we can restrain this within the screen bounds. And so far so good. It's going okay. If I add use gravity now, you can see it falls down, and then we can move. We click the game, and you can see when we move off we fall. So we're moving, and it's a great step forward. So thank you guys for watching this video. If you enjoyed it, don't forget to hit me a thumbs up and subscribe for more of my content. Thank you for watching. See you in my next video.